Away we go. Yes. Okay. All right, team, here we go. Welcome to our theme, program test, something comfortable for all of you with fourth. As we know, we should test incrementally with fourth. The beauty is that you can recompile little chunks of code right on the fly, perfect it as you go, integrate your test routines along with your code. So if you have sequences, as I do, of 1 or 2 words of code and then a test routine, code test routine, after a while you say, well, I'm testing and retesting code that I know is good. So I want to skip over the earlier test routines that I know are good, but I want to be able to come back and reactivate them. So selectively, we want to activate our test routines and then skip over them and bring the test sequence only to the latest code. So we need an adaptive selection done before testing. However, if we make a major change somewhere along the way, maybe we go back way early in the code and we make an early change, we want to restore the full testing for somebody's doing their dishes, it sounds like. So the major point, we want to be very selective on our testing and yet very flexible when using it when it's needed. So our typical outer level interpreted selection routines are paren if, or bracket if, else, and then. A typical example here is that we start F with a flag, a true or false value. It's applied to the bracket F. If the flag is true, then the sequence after bracket F will execute. That is a true code. However, if F is false or 0, the else part will execute. And we run the false code, and F will then, or the if will then finally terminate execution at the then. So this operates just as the compiled versions do. However, this operates in the interpreted fashion. So we see the selected execution of the true part or the false part based on the Boolean F. And the cleverness in this is that F is an immediate word, and it contains its own little mini interpreter. It actually escapes momentarily the fourth outer interpreter, and it does 2 things. It scans ahead for else and then, but if it at the proper point, it will then revert to regular fourth interpretations. So it's an interpreter, and it wrapped around internally as the fourth outer interpreter. So it's very, very clever structure, very flexible to allow us to selectively execute pieces of code. So now, in applying the if, how do we use this to selectively activate test sequences? Well, here is my variation on if, or my utilization of if. Begin with a value called test limit. And in this case, I've assigned 7 to the value test limit. Test limit can be anywhere from 0 on up. If test limit is 0, all test routines will execute. Otherwise, we can set test limit to a higher value, and it will selectively test later sequences. In place of the bracket F, I'm using star if. So star if takes a single parameter of it's an N here, but it should be an F for a Boolean flag. So the star if takes a parameter. It says, is it greater than the test limit? And is the test limit non-zero? If so, it will then execute the bracket if. Now, bracket if is an immediate word, and therefore we have to preface it with the bracket compile. So in this case, we have a simple modifier in front of the bracket if that looks at test limit. If test limit is non-zero, it will If it's 0, it will execute always, and if it is non-zero, it will execute when greater than the test limit. So the magic is all done in one simple line of forth. In a D-chart format, so we see it's expressed as the leading in code module that we want to test. And then we give a simple n, which is our test number, and then the star if. So sequentially, the early tests start out at 1, 2, 3, 4, 5. As we process through our code, the higher, later code sequences have a higher n number. And so if the n meets our input test, we execute a little code fragment, report if necessary, and then continue on code. If we are below the n level, then no action is taken. So here's an example of testing that might be at phase 8. At our 8th test section in our code, we hit star F. If our test is allowed, if our test limit is set to 7 or less, it will do the dot paren, which will give us a little report. The little report will say, this is the 8th test, and it's the test of a routine called subrandom. So that tells us where we are in the sequence. And then we apply the following code, which is written in this matrix language. And we put some input parameters to the routine subroutine and list the output. The A bracket list at the end lists our result. So we've generated a subrandom matrix, and we want to take a look at it. And sure enough, we see the header comes out to say 8 test of subrandom, which is in that bracketed quotation. And then we see a matrix has been generated with random numbers in the lower right-hand corner. So our routine is operating properly. The if-else-then structure can be nested, can be expanded to include an else. So in this case, we now see we have a code module we're testing. We give it the test level number and then the star if, and then we have a choice of executing 2 test possibilities. So in this case, we're going to test all the math functions. We're going to test plus, minus, and divide, not all functions, 3 functions. So this is our 4th test in sequence. We give a series of parameters in the 500, the 100, 500 plus 2 minus 4 divide 100 equal. So we go through a test sequence of the 3 math operations. And if they operate correctly, we will get the number 100, which is expected. And if they are in error, then we're going to ring the bell 4 times. And there are 2 messages. The first message says we got the expected 100. The second message says we have an error in the operators. And then we wake up the operator by 4 bells. In this case, the test goes properly. We got the expected 100. And this is an example. If the operators are in error, we'll see the introductory message, and then here you go, ding, 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 ding. So it's very interactive. It'll wake up the operator if there's an error in the process. There's a little more involved testing. This test 7 looks at the execution of creating a series of literal values, loading a matrix of literal values. So the 4 create bracket, A bracket creates a matrix on the following 2 lines of code, loads it with 4 by 4 value. The A bracket list will list it, and then the fill fills it again. The test routine, actually this whole thing is the test routine. So it in the test routine, it creates these matrices and loads them and displays them. And sure enough, we get a fairly elaborate test routine here, which has created those matrices and loaded them with values and displayed. This is a real life value. This is a little screen capture that shows how the test routines work. In this case, we're executing all the routines in sequence. So this tests the entire library that we are building. We'll take a little back look to scroll through and see all the tests that were done. So I do go to elaborate effort when I'm doing a major program like this to build some very substantial test routines. And of course, we don't want to go doing all of these test routines all the time. So that's why it is so satisfactory to have selective testing. As some comparisons, if we did the full testing, as I showed a moment ago, it adds 5.5 seconds. So when we recompile the system, we have a time penalty of 5.5 seconds to do full testing. Compare this with other languages, by the way. I mean, they're lucky if you get a compile time of 5 seconds, and here we get a complete compile and all testing in 5 seconds. If we set the test limit to 0, we will have no testing done. We recompile, and the entire recompilation is 26 milliseconds. So you can see the trade-offs we can do. If we only wanted to test the last couple of routines, it might add a half a second, maybe 1 second to the entire recompilation. So the benefits, well, we're thinking most clearly about code just after we have written it. And in fact, the test routines are very helpful because if you come back to code that might be 6 months or a year old, you have an example of usage. So you have a tutorial on usage in your test routines. So at the time you've written the code, best time to write the test methods. And of course, you're testing the test methods at the same time. Also, you've preserved these methods in your source code. So again, when I come back to something a year later, I have my own tutorial built in. So these are the references on this. In Europe, the Euroforth group have done some interesting testing. And so if you go to the Euroforth conference, the Euroforth 2019 papers, under Hoffman A PDF, you'll see a test method they did that is briefer, but I think less flexible. The another series was in you can find on the forth2020.org documents, and also on GitHub. There's one called Simple Tester. I'd like to thank Andrew McEwen and Tom Zimmer, who created Win32 Forth, and the Europeans who updated it for 2020. And the material you see today presented is at my GitHub. So just go to GitHub, Bill Ragsdale, and you'll see the program and test routine. And you can also get my guide to Win32 Forth. So I'll see you guys on GitHub someday. And back to Kevin. Thanks for your rapt attention.
Or unwrapped, as the case may be. So, Bill, how's the book coming? What's the publication?
Oh, the book has had zero progress in about 6 months. It turns out I have another life. I have several other lives. One of them is I manage an amateur radio repeater, and the other one is that I gave I did a 5-episode series on repeater management. So internally, if you're interested in ham radio repeaters, go to K6KN space Bill on YouTube. K6KN space Bill. You'll see a 5-episode videos on repeater management. I made the mistake of promising to do this some months ago on a weekly basis, and so it ate up 5 weeks in a row generating that series of videos. And then finally, I did an advanced lockpicking class in Los Angeles, and that chewed up 100 hours working on that one class. So I have a reasonable excuse from no progress on my 4th book. However, I've cleared the decks, and all that other stuff we've talked about is fading away. So the book will come. Okay, back to Kevin.
Are you interested in giving the advanced class, like your original lockpicking, or maybe a reiteration of the original lockpicking class to some select group of us? as previously experienced?
Well, there's two answers. The short answer is no, and the second answer is there are alternatives. Um, the advanced class um, um, is kind of like a kamikaze suicide mission because I as part of the class, the members got to take home all of the supplies. So they took home everything. They took home vices, picks, uh, 5 locks, handcuffs, combination locks, everything. And so I have no material left to do the level 3 anymore. However,
Vices.
the good news is I am posting the level 3 content on my Zoom channel. So it'll be a series of 4 videos that will lead you through advanced lockpicking, and you can watch them on video on YouTube.
Can
And
you send us a link?
again,
Send us a link.
I will when they're posted. They're not posted yet, but um, I'm in the final stage of the post production on the video on the 4th one. Again, these are major epics. I got about 20 hours into producing that first video. After that, they're going to go much faster. But it's been a wonderful learning experience in video production, tabletop photography, small cameras, GoPro, doing everything on velvet for lighting. You wouldn't imagine what it takes to turn one of these out, but you would imagine. Anyway, more to follow. Kevin's muted.
Thank you so much, Bill. I'm very grateful to you for your continued participation, if I may say that, in the massively understated Highland style in one of his military stories. One of the highest laudatory phrases was that you acted in consistency with the principles